Welcome to lesson 3.4, Equations of Lines. We're going to jump right in to this lesson video. So hopefully you've already taken a look at the lesson. A lot of this should seem like review, but there are some new things, some things that still need to be worked on. So please make sure you're paying close attention and listening carefully, as well as following along with the writing. Previous lesson, we found slopes of lines. You used your slope formula. Remember, that is rise over run on a graph. And in the coordinate system, it's y2 minus y1 over x2 minus x1. All right, and now we're going to take what we've done about slopes and what we also looked at with slopes of perpendicular and parallel lines. We're going to write an equation of a line given the information about that graph, and we'll also be doing some graphing. And we're also going to do problem solving by writing equations. So first, let's start with this. There are two ways that you can write the equation of a line that we're going to use, especially when we're looking at slope. There are two ways that use slope. The first is called y equals mx plus b, where m, the number in front of x, or the coefficient of x, is the slope of the line, rise over run, and the y-intercept is b. This constant at the end of your equation, plus or minus a number, is your y-intercept, meaning where the line would cross the y-axis. Okay. Once again, slope is m, and there's your example, and your y-intercept is b. But in point slope form, we have a little bit of a different set of information. You are still using the slope of a line. M is still the slope of a line in this formula. Y minus y1 equals m, parentheses x minus x1. M is still your slope. But the coordinates, x1 and y1, are the coordinates of any point. And so we don't have to just use the y-intercept. We can use any point on that line from our graph. So x1 and y1 are those coordinates. Now I do want to point something out to you. If I have my example here, 3 is the x-coordinate, and so notice I write x minus 3, because we want the difference of those values. So the coordinate is not negative 3, it's positive 3. And the same thing for the 5. Now, if it were to say y plus 5, we got a plus by subtracting a negative. And so we want to take the opposite sign from whatever is in our equation if we're looking at that coordinate. Or if we have coordinates, we want the opposite sign when we put it in our equation. And we'll talk about that as we go through our examples. Okay? Now, these work for any lines that are not specifically horizontal or vertical. Horizontal and vertical lines have unique equations. A horizontal line, I'm going to give you an example of a horizontal line. Something like that. Let's say that that was the x value, that was the y value on this y-axis of 2. Well, anywhere on that line would have that same y value. And so this line has a slope of 0 because it's horizontal. And since that's the case, I really don't want to write an equation in this format, but you can see the slope is 0 and the y-intercept is 2. So if I did write it in slope-intercept form, it would be y equals 0x plus 2. But we can simplify that because 0 times x is 0. And so our x has really been eliminated. And 0 plus 2 can be further simplified to just 2. So you notice that the form of our equation is just y equals 2. And because of this, every horizontal line I can come up with for a graph will always be in this form. Y equals some constant number, the y-intercept. For a vertical line, it's a little bit different. Vertical lines do not have a slope that can be talked about. All right, because they are vertical, we have an undefined slope. So I cannot use slope-intercept. But what you do notice, let's say in this case, that the x value is 2 on the x-axis, the x value is always 2. No matter where I make a mark on that line, that is still the x value of 2. And since this line represents every point where x equals 2, that becomes the equation of the line. And so vertical lines will always be of the form x equals some constant number, and we use the letter a to represent any number there. So if it's x equals a constant number, it's a vertical line. If it's y equals a constant number, it is a horizontal line. Alright, so we're going to practice graphing some problems. I'm going to do some of these and then let you try and do some on your own and give you a chance to check your answers. But first, we're going to try using slope-intercept form. In this first example, we are using slope-intercept form, which is y equals mx plus b. And we're going to write the equation from the given information. First, they give you a slope of 6 and a y-intercept of 3. So they give you the two pieces of information you need to plug in. And all we are doing is using our substitution property. 6 for m, and we're going to also substitute -3 for b. So when we go to write our equation, y equals mx plus b, you're going to plug in 6 for m and -3 for b. So our equation becomes y equals 6x, and instead of writing plus -3, plus -3 is really just -3, and so we can write that. And that's how we write our equation. That's the first part of what we're supposed to do. Now we want to graph that. And so we're going to practice graphing following these steps. First step, find the y-intercept. Now in our equation, it's that -3, but it's also given to us in our words up there. That is the first point we will plot, the y-intercept. Our slope will tell us how to find a second point. So first we're going to plot the -3 value on the y-axis, which is right there. And then our slope could be written as a fraction, 6 over 1, so that I get a rise of 6 and a run of 1. So from this point, I'm going to go up 6, 1, 2, 3, 4, 5, 6, and I'm going to go to the right 1. If you want to draw arrows, you can do so. And that's where we get our second point. As soon as we have that point, we can graph our line. So you take your straight edge, and you line it up, and you graph the line that we just came up with an equation. So part 1 is writing the equation, part 2 is graphing the line. Once again, this type of example gives you the important information. So in your example here, you're going to do this one on your own. You have the slope of -1 and a y-intercept of 4. I want you to pause the video in just a moment so that you can write your equation in the correct form and also graph it using that information. When you are finished, continue watching the video to check out our next examples after checking your work. Alright, if you need any more time at all, pause the video, otherwise this is what we should get. Also, please don't just copy down the information, make sure you've attempted this one on your own first. Since our slope is -1 and our y-intercept is 4, the equation you should get is y equals -1x plus 4, and your graph should look like this. Alright, now to use point-slope form, which is y minus y1 equals m parentheses x minus x1. In order to use that, we need to know the slope still and the coordinates of a certain point on the line. And so what they've given you here, again, is the slope, so that's m, and they've given you x1, y1 to plug into this formula. So once again, we are going to substitute using that substitution property. Instead of m in our equation here, we're going to write -3/5, and instead of x1 and y1, we're going to write -10 and 8. And so I'll show you how we do that though. Here's your formula again, y minus y1 equals m parentheses x minus x1. The m is an easy substitution. Just plug in -3/5. This x is still part of your equation. The first y is still part of your equation. You're replacing these that have subscripts. Now, if I'm to subtract the y coordinate is 8, I can just write -8. I'm actually going to take the opposite look for the sign from this ordered pair. Since it looks like a +8 here, it's going to look like -8 here because we're subtracting 8 from the other y value. And then for the x's, the same thing. I'm going to subtract that -10. Remember that, I'll put a note under here, x minus -10 is really x plus 10. And so I'm going to go ahead and write this as x plus 10. And so that is how you write your equation in point-slope form. And to graph that, we do not have to change it back to slope-intercept. You can, but it's going to be a little tricky when we have fractional values for slope. So in order to graph this, we can actually graph it in this form by using this information. Negative 10, 8 is the starting point instead of the y-intercept. So we're going to graph this by first plotting the point negative 10, 8. So we're going to go back to negative 10 and go up to 8. We're going to start there instead of the y-axis. From there, we're going to find a second point by using our slope. Our slope is down 3 and to the right 5. Negative 3 means you go down 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5. And now that we have our second point, we can line them up with our straight edge. And graph our line. Okay? I want you guys to try this next example on your own. Again, use the given slope for m and use the given ordered pair for x1, y1. Pay attention to negative signs. Alright, again, if you need more time, pause the video, otherwise we should get this. Y plus 3, because we're subtracting a negative 3 for the y value, equals 1/3 parentheses x minus 6. And your graph looks like this. Alright, now for these next problems, we can be given a lot of different information. We're going to get through some of these, but not every single one. Okay? So we could be given just 2 points. Alright? But that's enough information to calculate slope and to find the y-intercept if we do this right. And so in this example, here's what you want to do first. We want to write our equation in slope-intercept form, which is y equals mx plus b. So I need the y-intercept and I need the slope. I'm going to show you the shorter way to do this, in my opinion, which is to use point slope first. And then we're going to change it into slope-intercept. First, you need to calculate the slope. Okay, so m equals y2 minus y1, so we would do 0 minus 9, over x2 minus x1, negative 2 minus 4. And we need to simplify this into an easy to write slope. 0 minus 9 is negative 9, negative 2 minus 4 is negative 6, negative 9 divided by negative 6 is positive 3/2. So that's your slope. We want to now plug that in to this form, point slope, and then we'll change it into slope-intercept. Okay, now we used 4 and 9 as x1 and y1 in my slope formula. So those are the two I'm going to use to find that. So I'm going to plug in y minus the y1 coordinate, which was 9, equals 3 over 2, parentheses, x minus the x1 coordinate, which was 4. Now to change this into slope-intercept form, we're going to first distribute. So we leave the left as y minus 9. Then we are going to distribute 3/2 x to, 3/2 to x and 3/2 to negative 4. A positive times a negative is still a negative, so I write my minus. 3/2 of 4, the 2 and the 4 will cancel. 4 divided by 2 is 2, and then I multiply by the 3, so that's 6. And now to finish this off, all we have to do is get y completely by itself by adding 9 to both sides. So our slope-intercept form is y equals 3 over 2x, and then negative 6 plus 9 is positive 3. And that is your answer. Okay, we're going to skip over the next example. If you would like to try and do this one on your own, you're welcome to. But the rest of these examples we are going to try and cover in class on block day.